This example comes out of section 9.3, connecting graphs and rational equations. So in this question, we're asked to determine the roots of this equation 14 over x minus x plus 5 equals 0 algebraically. I'll focus on algebraically for the remainder of my examples just because I'm pretty confident by this point of the course you guys are able to graph and find solutions by finding intersections or by finding x-intercepts. So here, look at this question. There's nothing to factor, so my thoughts are to multiply everything by x. So I'm going to have 14 minus x squared plus 5x equals 0. Remembering, of course, that x can't equal 0. That's my non-permissible value. Now, to solve this thing, I would generally make it so that I like my x squared to be a positive term, so x squared minus 5x minus 14 equals 0. Factor it, and I've got x minus 7 times x plus 2. And so I get two possible answers, x equals 7 and x equals negative 2. My only non-permissible value was that x can't equal 0. I can check both these answers, but I should find that I have two good answers here. Some students have trouble with that instruction. It says determine the roots. Basically, they're asking for the solution to this equation. What does x have to be to make this equation equal 0? So these two answers should both work. In the second example, very similar, but we're just asked to solve. Again, algebraically, again, because I'm confident you could put in y1 equals 2 minus 3x over 2, and y2 equals 1 plus 4x minus x squared over 4x plus 10. If you're careful with your brackets, second, trace, intersect, find your answers. Here, my first step in solving these ones is to factor any denominator that I can. Nothing on the left really changes, but on the right side, I can at least take out a 2, and be left with 2x plus 5, which means when I decide what my non-permissible values are, I only am looking at what makes 2x plus 5 equal to 0, and so x can't equal negative 5 over 2 is my non-permissible value when I get later in the question. Now my common denominator is 2 times 2x plus 5, so I'm going to multiply everything on both sides of this equation by that. Everything on the left side, everything on the right side. Now, on the left, so that's going to give me 4 times 2x plus 5 minus 3x times 2x plus 5 equals, and on the right side, everything in the denominator did cancel out. And so I have this. Best thing about that step is that you no longer have to deal with rational expressions. You no longer have denominators whatsoever. So from here, I'll get rid of all my brackets. At this stage, we have a quadratic equation similar to something you would run into in Math 20. And so you want to group all your terms and put them to one side. And you end up with this equation, 5x squared plus 11x minus 19 equals 0. In an ideal world, everything factors nicely with nice even round numbers. In this case, I would be looking for two numbers to multiply to negative 95 and add to plus 11, and I can't think of any, so I'll jump right into the quadratic equation from here. If you put in the numbers carefully here, you've got negative 11 plus or minus the square root of 11 squared minus 4 times 5 times negative 19 all over 2 times 5. Numbers don't work out beautifully. You get negative 11 plus or minus the square root of 501 over 10. For decimal approximations, we're going to have x equals approximate. Two ugly looking decimals that need to be rounded. No rounding instructions in the question, so I wouldn't be too picky about it, but x equals approximately 1.14 and x equals approximately negative 3.34, and remembering our non-permissible value was x can't equal negative 5 over 2 or negative 2.5. So two solutions, just again showing that not all answers give you an answer like 7, I suppose. Hopefully we don't run into too many of those.